Welcome to the second video that we've got in our series of 3 on wave speed. This is the one that we're going to study, the wave equation. Now, the wave equation was the first equation I ever learned in physics a long time ago. It was about 1979, as far as I can remember, that my teacher showed me this equation, and it's one of the most useful equations that you'll ever have for physics in general. So that's the wave equation. Instead of v equals d over t, it's also true that v equals f times lambda. Okay, in other words, the wave speed is the frequency times the wavelength. Now, this can be changed into two alternative forms. So the first one is frequency is speed over lambda, all right, or over wavelength, v over lambda, and the last one is lambda is v over f. Okay, the wavelength is the wave speed divided by the frequency, and you can get that from this triangle over here. Now, not all of this is in the book, so you can just take this down as little notes as we're going through this. So I want to show you this example. Again, it's not in the book, this one, but I wanted to show you this y v equals f lambda. So if you look at this one, it says a wave has a frequency of 2 Hz and a wavelength of 3 meters. What is the speed? Well, the solution would be that v equals f lambda. F is 2 and lambda is 3. So when you multiply them, you get 6 meters per second. The trouble is, why? Why does that work? Well, remember that speed is the distance travelled in 1 second. That's from the dynamics course. So the distance in 1 second, what would that be? Well, if you think about it, 2 waves, 2 Hertz means 2 waves in 1 second. So in 1 second, you've got 2 waves, all right? There's 2 of them. And each wave is 3 meters long. So the total distance would be 6 meters, 2 lots of 3. So we just take the 2, the frequency, and multiply it by 3, the wavelength, and of course we get 6 meters. So the wave speed would be 6 meters per second. So the distance in 1 second is always given by f times lambda, and that is the wave speed. So that's why v equals f times lambda. So the example in the book says a sound wave travelling at 340 meters per second has a frequency of 256 Hertz. What is the wavelength? Well, we just use the formula. Lambda is v over f. V is 340, f is 256, and I make that out to be 1.33 meters. Let's go on. So we've got these practice problems here. First practice problem is the frequency of sound coming from a loudspeaker is 170 Hertz, and the wavelength is 2 meters. What speed do they travel at? So we just put them into our formula. V equals f times lambda, so it's going to be 170 times 2, which is 340 meters per second. Again, you should remember that from the previous one. Sound travels at roughly 340 meters per second. Number 2, water waves of frequency 4 and a wavelength of 50 centimeters travel towards a ship. What speed do they travel at? Again, we're going to use v equals f lambda. F is 4. Now be careful, because you could put lambda as 50, and it's not. It's 0.5 of a meter, so you would get 2 meters per second. Number 3, if the speed of sound is 340, what is the wavelength? Sound waves of frequency 512. The wavelength would be v over f, which is 340 over 512, which is 0.664 meters. Number 4, water waves travel towards a lifeboat at a speed of 2.5 meters per second with a wavelength of 0.5 meter. What is the frequency? So for that one, we'd use the other formula. F is v over lambda, which is 2.5 divided by 0.5, which turns out to be 5. Now, there's a mistake. That should be 5 Hertz. Okay, so the frequency would be 5 Hertz. I think what I'll do is, just for completeness, I'll do that as well. So number 5, the last one, is now this is the hardest one. So a water wave takes 1.5 seconds to travel 6 meters. If the frequency of the wave is 2 Hertz, what is the wavelength? So you think, well, wavelength, so that's just going to be v over f. Yeah, but what's v? We know what f is. F is 2, but what is v? So you're not given v, you have to work it out. So we're going to use v as distance over time, just the same as before. So it's going to be 6 meters divided by 1.5 seconds, and that gives 4 meters per second. Now we've got v. So now we can put in lambda. So lambda is v over f, which is going to be 4 over 2, which is 2 meters per second. And again, just for completeness, what I'll do is that I'll just bring that up there just to make it nice and good for you folks. So hopefully that's us. That's all that you need for v equals f lambda, and it's 2 variations. Just practice it and get good at it. And the next one I'll do, I won't release it today, but in the next few days will be a special video on sonar. Now this is a classic thing that we can ask you in an exam. Sonar is one of the classic ones to ask, but also because you people are going to be working at sea, this is a really applied example.